Where's that camera? Where's that camera? I got him. Nailed me. Who paid you to do that?
Hey, just wait.
It was a hot, muggy day in August as we hiked toward one of several caves we would visit this weekend. None of us knew quite what to expect, but the chance to see cave life with a couple of speleobiologists was just too good to pass up.
Cave! Tim, it's limestone. It's gotta be a cave.
Yeah, right there.
Yeah, this is Sinks of the Run, and as the name will imply, obviously looking down on the upsides here, the water when it's, after a good rain anyway, tremendous volumes of water come through here. So this is basically a swallow hole entrance. And today we'll get wet up to about here, but there are lots of times when wetsuits and all that, so we're going to get a lucky shot at what we're seeing today. What I'd like to talk about just briefly, though, is that, remember last night I mentioned to you a little bit about zonation. And here we are at the first zone that is part of this entrance area. And so what you're getting here is tremendous impact of the surface. All the production that's going on in the forest, all of that ultimately gets flushed into the system. So this is primarily a detritus-based cave system. In other words, most all of this is material that's produced on the surface in the form of plants, and then that plant debris and matter gets flushed into the cave. So in the entrance area, you're going to have a fair amount of organic material. Plus, you're going to have a lot of organisms that transit in and out of the cave system. So probably, and I think we should spend some time looking around here, some of you have already done that, and recognize that most of the things you're going to see right here are probably forest organisms, species that would typically be found in the canopy and certainly in the forest undercover, etc. So this is going to be a very heavily dominated surface community. As we move into the twilight zone, which is where we can still see daylight, but you're not getting direct sunlight, we start dropping off. We don't have as much movement, although this is a fairly short twilight area, so you're probably still going to be pretty heavily dominated by surface organisms. And then we move on into the inner cave for a certain distance, and it's going to vary from time of year, but you will see some fluctuation in temperature. So we get into this variable temperature zone, as opposed to a constant temperature zone. Again, like we talked about last night, that's not truly constant. It's just much less variable than we have out here. So that's the major zonation. In the entrance area, you can notice not only the insects and probably some crayfishes down there and other things, amphipods, but notice up underneath this ledge, there are a couple of phoebe nests. In other words, birds that are coming in, moving, using this area for nesting. So that's just a very typical sort of entrance combination. You see a lot of green mosses, we might have liverworts, ferns that are all right here, and then as you move in, all that drops off. So it's pretty much low light species tolerate the entrance area, and the further you go in, the less and less algae, moss, and those kinds of things. Take a look at this pool. Did everybody see the little salamander larvae that are here, and the water striders, and I think there was a crayfish in here. There's several there. Good. Okay, yeah, great. I think one of the things to think about these organisms is that for the most part they're scavengers or opportunists. A little bit of organic matter and they're happy. They're not that much of a specialist as feeders. So the vast majority of them at least will take what they can get. Oh, what you got?
Good cheese, you'll have better.
Yeah.
But he's on black.
Yeah, he's on black at least. Better than... Okay, gang, want to come look at this little millipede?
Oh, yeah.
There you go.
White millipede.
Yep. That probably is cave adapted, but it's hard to say because you often, particularly when they're small, they're not very...
White, right there.
There's another little cricket, but same right. If you got that, it's the scorpion.
See?
Yeah, good. Can you get him up on something? Go put him in there?
There's a tiny little black one there.
Yeah.
Well, there's another one.
Zipping.
You go from one out
Okay.
to the other.
Up on here.
You didn't want to jump here.
There's him there? Nope. There they are.
Two of them.
There we go. These are pseudoscorpions. You have to look very, very closely to find these. They're a little bigger than the head of a pin, depending upon what species and all, but they're teeny. And in case somebody came in late, that's probably a Keen's batter, a Myotis, anyway. And during the summertime, they are in caves to the mycelium, the body of the fungus, and it's just helping break down this piece of wood that's washed in.
So how long would it last? This was found in that pile.
And theoretically, until the wood is completely broken down.
So that might be years?
Yeah. Mm-hmm.
How does it come in here to begin with?
Well, it probably
down?
comes in actually on you can several ways. You can get spores that wash in or blow in, or it may have even already been on some of the wood that would be coming in. But that's then the spores germinate.
Is this like a day's growth? Or
No,
just
that'd be that'd be a long period of growth to get those kinds of spikes. I don't know which one that is, but yeah, you do get slime moles in caves.
This is as deep as it goes, I think.
Oh, this is gold.
What do we got here, huh?
This is really a neat situation. It's got a couple of live Cameron's Bartonii, the large surface crayfish, and looks like remains of another one that's trapped in this pothole here a few feet above the stream, at least at this moment. And in any case, one of them may be a male, but the one over here is certainly a female with her abdomen folded up under it, and there's some red eggs. You see them just at the edge of their the uropods, the back of the abdomen of the female. And I'm really wondering if that's the male. Of course, you look down the side, you can tell.
There's a standard rule that when you're caving, if you think about it, if suddenly you see a lot of organisms, whether they're white, blind, or whether they're not, you should suspect that there's some unusual organic input. Now, in this case, when we go down here, the unusual organic input is clearly the flooding, the natural flooding that occurs. But in other cases, for instance, if you've seen some sections of the hole, in the Gibbs section of the hole, where there are lots of flatworms, it's not so natural. It's effluent from barnyard waste and also from the turkey farm. So one of the characteristics to look for is high diversity. When you see lots of animals, you're in an environment where there's no photosynthesis. In a place like this, there is no primary production. Only in unusual situations is there chemoautotrophy, that is, energy made from chemical reactions without the sun, and special bacteria that are required to do that. Everything has to be brought in. So if a lot's brought in, there may be more animals.
Yeah, they move fast.
Well, he's shocked.
Cricket right next to him.
Traumatized.
You guys see a little cricket that's right next to him, a little fly, teeny going? Can you guys see that right
Yeah.
by his head?
His mouth opens and out comes fire.
Right. You got a close enough view.
Dave, how much did you pay that salamander?
Placed in there, probably.
Strata or levels, and you get these ground up leaves here, and this is the base of the food chain for all of these things. This is what makes the cave unique. There are these great mounds of this stuff, and it's all chopped up. This is a fungal growth, and almost any sort of clump of organic material is susceptible to attack by the microflora, that is, the fungi and then also the bacteria. And you get those are mycelia from fungi that are going out, and they're basically feeding on the organic material as well. The role of the fungi and bacteria is probably the great unanswered question in cave ecology right now. And I think cave microbiology is really the wave of the future as far as research goes. So it's interesting stuff. And it's only endangered because of any species is found in only one cave. Right. There are some 50 single cave endemics in caves in the Virginias. So it's very unusual, not unusual at all to find caves, species known from only one cave. Most of these, I suspect, are not really cave animals, but rather things from the leprechauns. This is an unusual situation because it has two real cave animals that are endemic, the other one being a beetle. You will see in the just pour it over and then wash it into the net. The other thing we do is, I mean, if we're serious about it, is we take it apart.
Oh, the wing nut on the bottom.
What's its
Yeah.
purpose?
It's a substrate to
Artificial substrate.
And they're actually designed for diatoms and stuff like that, and they just decided they'd work in caves. And they do.
What do they mean?
They work extremely well in springs, too.
Man, look by your foot.
Oh, yeah, one of the white ones.
Oh.
So what's the idea? The critter is sort of hiding in between the plates?
Yeah. Yeah, there's one of the white ones. Toss it in the net if you can, Lynn. There's a larvae. This is a larvae of Gymnopolis subterranea.
That's just like the
Will they ever lose the gills?
Yes, they metamorphose.
eyes are
Very
covered
small,
over.
but they're there.
Or very tiny. Almost look like
Okay, I need to move back to light them up.
Nice kitchen tools, but they work very well for looking in here. What you want to do is remember that we said differences in substrate type. Here we've got fairly large cobble, gravel substrate. What you want to do is to lift those up, realizing that there are spaces called interstitial spaces between those, and that's where these organisms live. You seen any of the isopods? Remember, isopods are flattened top to bottom, and amphipods are flattened laterally or side to side.
Oh, I see a white amphipod here.
Do you? Great, that's Stigobromus. If we can get it, I don't know, you don't have any tools up here, do you?
another, but it's in a really shallow, tiny pool.
Okay. Now, this is a millipede, probably a big one. Are you able to even see this at all? Yeah. Very nice. Good. You get the Stigobromus, the white amphipod?
We got him on a rock. We got him on a rock. Put him in and rinse him off. Yeah,
Yeah, just put him in the bucket and they'll rinse right off.
Where's the bucket go?
Is that a Stigobromus? Oops. No, I just got a rock.
What is that?
What do we got here, Herb?
This is the troglodytic amphipod. This is called Stigobromus. This is the other one that's found in here. Don't really know why this one's here as opposed to being lacking in Sibley 3, but they share the same stream as the Gammarus minus. He's getting a focus on an amphipod. He's just cruising, isn't he?
You know, small animals that you need a magnifying glass for. So when you say there's a goer, there's a question here.
Okay, what we have is a mouse that has passed away. This is going to serve as, or has served as very good food for any organisms in the cave. What you see, the remnants of the tail and most of the skeletal remains are still there. This is an excellent food source for the terrestrial organisms that are found in this particular section. This is probably fairly close to an easy access entrance to this organism. It may or may not be actually the Sibley's 2 entrance. It may be a crevice or a crack that's close by, but these things are certainly going outside feeding and coming back in, probably even bringing some food with them. But at any rate, it's passed away, and so this served as a prime source of food and energy for cave organisms that are found in crickets. Probably the larger animals move into it first initially, and then other things find it as well. So it's a wonderful source of energy.
Eventually be a land deal.
No, that's the question. It's actually.
Oh, okay, now that's the only mark you can place the mine.
Did you have any of the Stigobromus, or is it all?
It's all Gammarus, as far as I know. Put it that way. Oh boy.
No, I didn't either.
Let's see, yeah, one more. Wait, down there, and get it. Okay, this is Eurycia lucifica, the cave salamander it's called. This is a troglophile, troglozine, depending upon how you define it. Typically it's considered a troglophile. They're usually found near entrances. Remember that we have an entrance further up here. There may be other cracks and crevices that can move in and out of. But this is a classic cave organism that is found not only in caves. We'll sometimes see them around entrances and even up on land. But for the most part, it's found in limestone regions where the caves are developed.
It was time to go, so we started out for the surface. We had seen life in the cave we'd never seen before, even though it had been there all along. We were all determined to observe more carefully in the future.